this so that you, okay. So in this talk, I will talk about like another 40 to 50 minutes time, and then Yasara will continue with what is remaining. So in this one, I'm going to focus on 5 basic algorithms. 5 basic algorithms so that you have the basic understanding of machine learning algorithms and how to apply them. So those basic algorithms are, we call OneR, decision trees, decision rules, nearest neighbor, and naive Bayes. Now, if you ask me why these 5, this is specifically focusing on 5 different paradigms, like they have differences which you need to understand. So that's why we will discuss these basic algorithms. Right. Now, in many cases, in machine learning algorithm, now we have very advanced algorithms. Completely agree that you should try with them. For example, some of you might always think, okay, deep learning algorithms might work. No, it's not like that. So usually as a practitioner, what we recommend you to is you start with the simple algorithms. One of my professors used to say that, okay, he works with many companies and most of the time he uses simple linear regression. I hope you know what linear regression is. And quite often he uses the simple algorithm. So in machine learning, we believe that most of the time, right? Most of the time, simple algorithms will work in your problem. So try with simple algorithm. And if you're not happy with their accuracy and the performance, then move towards the more advanced algorithms. And you should not start with the other way around. So that is one of the things, because, for example, if you look at like deep learning neural networks, for example, it's the cost a lot, huge computing power we need, right? Which you can save the planet by incorporating these simple algorithms. So when it comes to back to simple algorithms, there are many simple kind of structures. So what we are going to see in today is some algorithms we say one attribute is enough. What do you mean by one attribute? You know, when you're representing our problem in a data set, there could be several attributes, which means we are going to keep record of set of attributes. But what we are saying in here is one attribute is enough to make the decision. And I will show you, that is what I'm going to do. I'm going to show you that, okay, so based on one algorithm, we can make a decision, right? That's the first one. Second one, we say all attributes contribute equally and independently. So some algorithms, they treated everything is equally. So that means some algorithms, it will consider all available attributes, right? But there are like some assumptions. For example, we can assume that, okay, attributes are independent of each other. Third one, a weighted linear combination might do, which means in, for example, in numerical prediction problem, simple linear combination of weights is enough. So that is another type of attributes, another paradigm we call it. We'll discuss later, separately. Fourth one, instance based. Now, all the previous 3, we are going to create some kind of a structure, or we can say a model. But sometimes we are not going to create a separate model, but we use our instances. That means our training data as our model. That's what we call the instance base. So nearest neighbor like algorithms, which always assume, okay, instances will represent the model. Last one, use simple logical rules, right? So although we have many, which one works well actually depend on the domain that we are working on. Therefore, you should have a good understanding about different types of machine learning algorithms. At the same time, you should also have an understanding of where this particular algorithm is working, right? So with that only, you can move forward. Right. So let me start with OneR. We call this as a single level decision tree. So what do you mean by single decision tree? So which means that one attribute is enough. Therefore, what we do, we will have a set of rules to test a particular attribute. Here is the basic version. You get an attribute, right? And you create one branch for each value. For example, in our toy dataset, I have shown you last time, we call weather dataset. I'll come to that point later on. We have outlook attribute. Outlook, we have three different values. Outlook is sunny, outlook is overcast, outlook is rainy. So that means we are going to create three branches. So likewise, for each of these different values, we create branches. Second point, for each branch, we assign more frequent class. Given you create a branch, we will look at with the data set what will be the final classification. By saying final classification, we can assign the most frequent class. For example, assume that you have positive and negative classes. Let's say you have 60% positive and 40% negative. So the frequent class is positive there. So likewise, you assign the most frequent class. Third point, we'll calculate the error rate. Now we are making a mistake, right? For example, if you say outlook is sunny, and if you say play is yes, outlook is sunny, then you are going to play the game. But we know that in some cases, even though outlook is not sunny, right? We don't play. Or we will play even without that. So that means we are making some errors. Originally we say if it is sunny, we play, right? If it is not sunny, then we have some other thing, right? So we are making errors. So we want to record this. So that means each of this branch, we have a error rate, and then we calculate for each attribute. Finally, then you choose attribute with the lowest error. Remember, in this particular case, we are going to assume that we have nominal attribute. What do you mean by nominal? You have a categorical data. I will explain with the example. Right. So let me start with the weather dataset. I hope you remember this dataset from our previous session. This is called weather dataset. We have 4 attributes: outlook, temperature, humidity, and windy. And based on these different weather conditions, we need to decide whether to play or not a particular game, right? So for example, if you read out the first row, it says the outlook is sunny, humidity, temperature is hot, humidity is high, wind is 4. If that is the case, we are not going to play the game. That's how it works. So the idea is we are going to use this data to make a model. And then when you get a new situation, we are trying to predict. So that's the understanding, or that's what exactly we are going to do. So having said that, right, let's start creating rules. The idea is, right, we will take each attribute one at a time, right? So for example, here is how we create attribute outlook and we calculate the errors. So let me show you how to do this. And then you should also work it out together with me when you're making that decision, right? Okay, so I'm going to go back and I'm going to show you how we are going to do this. So this is how we are going to start. The first point is we'll take each attribute at a time. So I'm going to take the outlook. So the point is I will start with outlook. Okay, given we have outlook, we have 3 different values, right? So what are the 3 different values? We have sunny. What is the other one? We have overcast. Third one, we have rainy. Right? So these are the values we have. Now we have to assign most frequent class. So let's work it out the most frequent class. So when outlook is sunny, we know play is no. We have sunny, play is no. We have sunny, play is no. We have sunny, play is yes. We have sunny, play is yes. So you can see here we have 3 no's and 2 yeses. So that means the most frequent class for sunny is no. So we put that is no. Then we make a mistake, right? Because there are 2 yeses. There are 2 mistakes. So there are 2 mistakes out of total of 5 instances. So this is what we are going to rectify, right? Now we can go with the next set. What is the next set? We have overcast. So when you have outlook overcast, it's yes. Overcast, yes. Overcast, yes. Overcast, yes. So which means now we can observe that, right? We can observe that whenever we have overcast, the prediction is always yes. So the most frequent class is yes, which means there's no error. We have 4 instances. Out of 4, 0 errors. Right, now the third one given to you, I need the answer in the chat. Tell me, given rainy, what is the frequent class and what is the error rate? Let's see who are going to answer my question quickly. This. So given the rainy, we can see the play is yes, rainy no, rainy yes, and rainy no. So we can see that there are 3 yeses and 2 no's. So the most frequent class is yes. So we can put rainy assigned to yes label. And the error rate would be 2 out of 5. And now we have done this, calculate the total error, that will be 4 out of 14. And remember, this is only for one attribute. So the point is, you might have to do it for everything, right? Each and every, we have done for outlook, similar to that, do it for temperature, do it for humidity, do it for windy. If you do like that, you will get a table like this, right? If you keep on doing this for all the attributes, you will get like this. So some places you might see a star, for example, here, temperature hot, then the classification is no, it's 2 out of 4, that is 50-50. So when we have a error number is 50%, that means it can be either yes or no. You have to choose wisely. In this particular case, I have choose no because all the other 2 is represent the positive yes. Therefore, I selected no here, right? So you might have to do some adjustment here. Other than that, that's perfectly all right. Now, which attribute is the best attribute now? We have to select only one. I need the answer in the chat. So OneR does is calculate the total error and select the attribute with the minimum accuracy. Sorry, minimum error. Maximum accuracy, it's minimum error. Yes, what is the answer? Given these 4 attributes, which one we are going to select as the attribute with the least error? Right. Okay. Okay, answer written back again. Okay, here is my answer, right? Why I'm saying that you will realize later on when you learn more machine learning algorithms. The first one is according to what we know about the algorithm. Both outlook and humidity, both can be the answers, right? Because what the criteria was to have the minimum error. So we have a tie here. Both outlook and humidity both received the total errors of 4 out of 14, which means, as Rangi said, both outlook and humidity could be the answer, right? So final answer, in my case, I have selected outlook, but somebody else can select humidity too, right? So that means answer is either outlook or a humidity. Okay, so I hope you got the idea of this. So whenever you have a, you want to do a decision because two errors are the same, then you can take one at random. So some can select outlook, some other can select humidity. Both answers are correct. Right. Now, this is the first one that I would like to discuss. But remember, the data set is categorical data, categorical or nominal. We say you have different categories, different values, right? No numbers, no numerical, data points. Now let's discuss how we can extend this algorithm to work with numbers, right? So what we are going to do in this particular case, given a set of numerical data points, we want to separate out, right? We want to sort instances according to the attribute values, and then we can look for the class changes, and we want to make breakpoints. Again, like in the previous case, we want to minimize the total error. Right. Okay, having said that, right, how do you do this? So now this is another data set. Actually, it's the same data set, but temperature and humidity columns are given with some numerical variables. And you see now there's a problem compared to previous one. Earlier we have clear separate categories, but in this case we don't have. We have just continuous value. It's not discrete anymore. So we have to make ranges, right? So the question is, how do you make the range? So what we are going to see here, we will have temperatures we get, and together with their class labels. For example, 85, the place no. 80, it's no. 85, 80, it's no. 85, 80, it's no. So you can see, we will list all the temperature values together with their class attribute. So you can see 65, it's yes, 64, yes, 65, no, 68, yes, and so on. Okay. Let's move on. The next point is you make breakpoints. What do you mean by breakpoint? Whenever there's a change of classes, we put a breakpoint. So from here to here, we are going from just class to no class, so we have breakpoint. Similar to that, we have no, right? Here we have yes, we have breakpoint. Then this is the same. Here we have different, we have breakpoint. Okay, you cannot put a break line here because you have the same values. Therefore, immediately after that, you can put a breakpoint. Yes. We have yes, yes, sorry. In this particular case, we can put, okay. Then yes, yes, we have a breakpoint. No, we have breakpoint. Yes, yes, we have breakpoint. So you can see 1, 2, 3, 4, 5, 6, 7, 8 ranges we can identify. Right. But you can see this is too much. Why I'm saying too much? Too many ranges. So let's devise a way we can reduce the number of intervals. So the idea that we need to discuss is called, right? We enforce minimum number of instances. We will say, okay, you need minimum number of instances in a majority class, in an interval. This is the procedure we actually follow. So let's say we specify minimum count of 3 from frequent class. What do you mean by frequent class of 3? Okay, you can see there's a difference between the classes. But we have only one class. So therefore, I have to move on. So when you are here, there's a change. But then again, not enough from most common ones. Then we go up to this point. We go up to this point. Then the no changes, we can put line like this. We specify minimum number of 3. So you can see there are 4. Similar to that, we have no, no, yes, yes, yes. Right? We have no, no. And then we have to separate it from here, right? So you have no, no, but you cannot have, then yes, yes, no. Sorry, we have to put 3, right? So we have 3 here. So no, no, yes, yes, yes. Minimum of 3. Right? So that's how we can separate down. But if you look at here, everything will be classified as yes. Everything is also classified as yes. What do you mean? You can remove this one. You can remove this line. So that means this can be taken as a single, right? Single. So you can make this part right? So you can see here now, we have everything classified as yes. Next thing, what do you think about the classification here? 2 yeses and 2 nos, therefore I will select no, but remember I will put a star. This could be even a star. Right. So now the split point is in between these two, that is 77.5. Right? So we can say if it is less than 77.5, that is yes. If it is greater than that, that is no. Right, let's see. In the next one, you can notice, yes, the updated table, the way we have discussed, we have worked on temperature. But if you work on humidity, that is what you should be getting. Right, given this, can you tell me which one is the best one? As Prasad correctly mentioned, this should be humidity, right? This should be humidity. Why? It will give you the, yes, the least error based on this. Exactly, Prasad. Humidity is the answer because error rate is the minimum. Now, if you're wondering whether this is a machine learning algorithm, of course it is, right? The remaining 15 minutes, let me discuss the implementation of this, right? So I'm going to show you how we could implement this in Colab environment. Okay, and then I will, let me explain the code for you and then you can implement. Uh, so WEKA actually is a data mining machine learning toolkit which is developed by New Zealand University. If you type WEKA 3, you can find their website and you can download and install. So since I'm going to planning to use Python coding, let me show you how we could use WEKA in Python. So since WEKA is actually written in Java, so we need a couple of things to do. We need to install JDK Java, and we have Python Java bridge and WEKA wrapper to connect everything together to make it a work in a Colab environment. So that's what you should do here. And once you do, and one more thing, this command like exclamation mark usually be used to execute commands in the virtual environment, which means we actually write in the Linux environment. If you are familiar with, these are the commands we use to execute. Right, but don't worry, just put these three, and then when you run it, it'll connect and install whatever the required uh, libraries. Second point, once you do that, you can check whether the Java version is working. So in the first command, I'm actually check the Java installed version. The second one is I'm actually looking for Java compiler version and then also the information about what we have installed. Once you familiarize with this part, then what you need to do, you have to do two things. You have to import WEKA for Java virtual environment, and you have to start the Java virtual environment. So you have to, use these three commands to set it up for the Java WEKA environment. So once you do this, it's a matter of connecting into the data set. So I am actually showing you how my data is there, but I will give you the data set for you. So that means we are going to read my data folder, and I'm going to read data. So this read data, it comes with a special format called ARFF. That is natural formatting available with ARFF with WEKA. So simply we load the data set and simply we print the data set, and it looks like this. So simply you can see the data set. We have outlook, temperature, humidity, and windy at the play. And in the curly brackets, it lists out the different attribute values. Now, once you do that, right, we are going to talk about OneR algorithm. And this is how we are going to actually write the code to run OneR algorithm. So you have to first import classifier. And within the classifier, we have to say which WEKA algorithm we are using. So under WEKA, under the classifiers, under the rules, we have OneR algorithm. Simply that is our model, and we build our model using our data. And then we print the model. And this is how you will get, for this example, it will output outlook as the final answer. And it says when outlook is sunny, you are going to classify as no, overcast, yes, rainy, yes. Right? So I hope steps are familiar to you. So I will share you the coding with you so you can get ready and try with simple data sets and see whether it's working. Okay, that's all what I had planned for today.